Hi, my name is Liv Jackson and my project is titled Towards a Better Understanding of Pesticides in the Atmosphere. Firstly, what is a pesticide? A pesticide is any substance or mixture of substances intended for preventing, destroying or controlling any pest. These include herbicides, insecticides and fungicides. The life cycle of pesticide is shown on this slide. We are interested in the atmospheric section. Here, the pesticide is applied to the field before atmospheric processes such as gas particle phase partitioning lead to long-range and short-range transport before finally deposition occurs. As part of my TBS, I underwent a short-range study. This is important in terms of pesticides, as 30% of applied pesticide is lost to the atmosphere by spray drift, and this has potential to be harmful to examples here. As part of the investigation, I looked at short-range transport models of droplets. For example, the Kulmala model, a semi-analytical expression to describe the binary condensational growth or evaporation, as such as equation 1, where I is max flux. XZ is also another model. This uses evaporation and momentum to calculate the change in radius per time, the change in temperature per time, the change in velocity over time, and the change in position over time. Using these equations, the single aerosol drying and kinetics and trajectories model was developed in Bristol, and this was based on the equations by XZ and is used in this study. The falling droplet column is a relatively new technique used to monitor the evaporation and trajectory of a falling droplet. The droplet enters the column using a piezoelectric microdispenser, and as the droplet falls, it is monitored by a stroboscopic camera and monitors the change in size and analyses the trajectory. At the bottom of the column, a plate collects the particles and this then goes on for scanning electron microscopy analysis. The results of this study is shown in brief here. The falling droplet column fit well with the new SADCAP model. However, the Kulmala fit poorly. This is because at dry humidities, the Kulmala does not account for evaporative cooling of the droplet, leading to deviations. The trajectory also fit well between the falling droplet column and SADCAP, and the difference in the X position here can be accounted for the difficulty in determining initial gas speed of the falling droplet column. Overall, my research aims to identify the gaps in understanding, investigate short and long-range transport, understand pathways of atmospheric transport, and further develop atmospheric aerosol models for prediction.